To linear motion. This is the motion of an object in a straight line. Examples of objects or bodies performing linear motion are an athlete running in a 100-meter sprint, a car moving in a straight line, a boy running on a straight track, or a train moving in a straight track. Anything that moves with changing or constant acceleration in a straight line is performing linear motion or rectilinear motion. Now, these are the parameters used for describing linear motion. First, number one, distance. Distance is the length of space traveled by an object, on road or maybe on a surface. Its symbol is S and its SI unit is meters. Distance is measured in meters. Displacement is distance traveled in a specific direction. Its symbol is also S and it's also measured in meters. Time is the interval between two events. So, for example, between the start and stop of a particular motion, the interval is called time. It's measured in seconds and it's symbolized as what? T. Next is speed. Speed is the distance traveled per unit time. The symbol for speed is U or V. U for initial speed, V for final speed. Both are correct. It's measured in meters per second. You will see how that comes up now. But let's treat velocity first. Velocity is the change in displacement per unit time. So, velocity is the change in displacement per unit time. The symbol for velocity is V or U. U for initial velocity, V. U for initial velocity, V for final velocity. And the SI unit. The SI unit of velocity is meters per second. Are you getting that? SI unit of velocity is meters per second. Now, as more note, speed, let's now write formula. Speed, we said, is what? Distance traveled over what? Time taken. Speed is distance traveled over time taken. So we can define speed as distance traveled per unit time. So V is equal to S over T. S is in meters, T is in seconds. That's how we came about the symbol for the SI unit of velocity as meters per second. Or we write it like this, or meters per second, or meter per second. So same thing, velocity. Let's go to the formula for velocity. Also, velocity is what? Velocity is equal to change in displacement. Velocity is change in displacement over time taken. Or we say change in displacement per unit time. So velocity is also S over T. Displacement is also symbolized as S, time as T. Displacement is measured in meters, time is measured in seconds. So everything, the SI unit is meter per second, or meter per second, or using indices S raised to power minus 1. Next is what? Acceleration. What number should that be? Number 6. Next is what? Acceleration. Acceleration is change in velocity per unit time. Acceleration is change in velocity per unit time. Acceleration is change in velocity per unit time. So that is acceleration A is equal to final velocity minus initial velocity. Final velocity minus initial velocity over what? Time taken. Final velocity minus initial velocity over time taken. We said the symbol for final velocity is V. That for initial is U over time taken. So that's the formula for acceleration. Let's now work out the SI unit. Note that we said that velocity is in meters per second. time is in seconds. So you have this over what? This. You understand? So that at the end of the day, you are going to get meter per second divided by second, which gives you meter per second times 1 over second. And that's what? Meter per second squared. We write it as meter per second squared like this, or meter per second squared, or meter per second squared. Any one of these three is, the SI unit of acceleration. Let's continue. Okay, I think that's all. Let's now go to derivation of the equations of linear motion. Derivation of the equations of linear motion. Derivation of the equations of linear motion. Let me change the ink of my pen. Derivation of the equations of linear motion. First, equation 1. The first equation in linear motion is derived from the definition of acceleration. Acceleration is change in velocity per unit time. So from here, if I put 1 under this and cross multiply, I'm going to get v minus u is equal to what? At. If I take minus u to the right, it will become plus u, and I get v is equal to u plus at. That's the first equation of linear motion. Take note. Equation 2 is gotten from the velocity time graph. This is a velocity time graph. So let's say this is velocity in meters per second. Let's say this is time in seconds, and an object starts its motion. Let's say an object starts its motion at initial velocity u and goes to final velocity v. So let me use yellow for this. In a time t. In time t. Let's say the time taken is t. We can put t here or put it here. Any one of the two, but let me leave it in the middle. So let's say a body starts moving from initial velocity u. Let's say a body starts moving from initial velocity u and moves for time t to a velocity what? V. To a velocity v. You understand? In time t. What we usually do is that the distance traveled is the area under the graph. This is a trapezoidal graph with two parallel parts. This part is parallel to this part. Now, the length of this part is what? V. And the length of this part is what? U. So, we now do area. Distance is equal to area under the graph. The graph is a trapezoidal one. So the area of a trapezium is what? Half open bracket a plus b times h. So that will be half open bracket. A is u, b is v, times what? Time. That gives us the formula for distance. Distance is equal to average velocity times time. Distance is equal to what? Average velocity. Average velocity times time. Average velocity is u plus v over 2 times what? Times time. That's the second equation of linear motion. That's very simple to remember. Just note area of the trapezium. Area of the trapezium is half open bracket a plus b times h. Your a and b are the two parallel sides. A is u, the smaller side, u here, and b is the longer one, the longer parallel side, times what? T. So if you put the two together, put 2 underneath them, you get distance is equal to average velocity times time, as s is equal to u plus v over t. Now, let's go to equation 3. Let's go to the third equation. The third equation is gotten from the second one. The third and fourth equations are gotten from equation 2. So from S is u plus v over 2 times t. From equation 1, we know that v is u plus at. So this place where I have s, I can put this place where I have s is equal to u plus v over 2. Instead of writing my v, I can write what for v? I can substitute for v by writing this expression for v. Instead of writing v here now, I'll now write what? I'll write u plus at. So I have v here, but instead of writing v, I'll just go ahead and substitute u plus at for v times t. I hope you got that logic. Instead of writing this v here, I'll change it to the expression u plus at from equation 1. Let me just indicate that this is from equation 1. Now, after writing s as u plus at, this will give me 2u plus what? At. So s is 2u plus at over t. Over 2. Oh, sorry. I've been writing t. It should be over 2. Excuse me. Over 2 times t. So, as we all know, the numerator should multiply the numerator. So I'm going to get 2u plus at times t all over what? I'm going to get 2u plus at times t all over 2 is equal to s. Is that clear? So my s will now be, expand this bracket up here. If I expand what's up here, what do I get? I get 2ut, 2u times t is 2ut. Then at times t also is at squared. So I get 2ut plus at squared over 2 is equal to s. So s is equal to, I can split my numerator, so I can write it as 2ut over 2 plus at squared over 2. Now, on this left side, 2 will divide 2. So I get s is ut plus half at squared. That's equation 3 of linear motion. That's the third equation of linear motion. S is equal to ut plus half at squared. Take note of that. Now, let's go to equation 4. Equation 4 is the same thing. Equation 4 is also gotten from equation 2. From equation 2, distance is average velocity times what? Times time. But from equation 1, which is v is u plus at, which is v is equal to what? u plus at. I can write that u plus at is equal to v. So at is equal to v minus u, and what? And t is equal to v minus u over a. Now, this expression v minus u over a, I'm going to substitute it for t when I get to, to write the expression in order to get equation 4. So when I'm writing equation 4, I will substitute t for what? I'll substitute v minus u over a for t. That's how we get equation 4. So my equation is what? U plus v. My equation 2 is distance is average velocity times time. But now, to get equation 4, instead of writing t outside, I'll just bring in v minus u over what? A. Let me write that in blue so the substitution step can be clear. So I'll just write s is equal to u plus v over 2 times v minus u over a. That's what we got from equation 1 for what? For t. So instead of writing t here, I'll just substitute what? V minus u over a for t. Instead of writing t, I'll write v minus u over a. That's an expression we got for t from equation 1. So let's now simplify. Let's now expand and simplify. Numerator, we multiply numerator. So I get u plus v times v minus u over what? 2 times a, 2a. This is going to give me u times v uv, u times minus u squared, v times v squared, v times minus uv, all over what? All over 2a. So what does that give me? That gives me what? That gives me uv minus uv minus u squared plus v squared all over 2a. I'm rearranging now. uv minus uv, 0. So that disappears. So I'll be left with minus u squared plus v squared over 2a is equal to s. Now, on rearranging further, I'll get s is equal to v squared minus u squared over what? 2a. I've just rearranged this numerator. I'll just rearrange this numerator to minus u squared. Minus u squared plus v squared can be written as plus v squared minus what? U squared. So that rearrangement makes my equation look more beautiful. So now, on cross multiplying, put 1 under this and cross multiply. I'll get v squared. What do I get? V squared minus what? U squared. V squared minus u squared is what? 2as. So to simplify further, v squared is u squared plus 2as. If I take minus u squared to the left, to the right, it will become plus u squared. So this is my equation 4. This is my fourth equation of motion. This is my fourth equation of motion. Let's now summarize everything. Let me summarize everything. Now, in summary, in what? Summary. In summary, my equations of motion are: equation 1, distance is what? Average. Okay, that was not the one I used for equation 1. My equation 1, v is equal to u plus at. Equation 1. Then next one, distance is what? Average velocity. Average velocity is u plus v over 2 times time. Thirdly, equation 3 is what? S is equal to ut plus half a t squared. Then lastly, equation 4, v squared is equal to what? U squared plus 2as. These are my equations: 4, 3, 2, and what? Equation 1. So those are my equations of linear motion. Those are my equations of linear motion. What you should do now is very simple. Try to close your note, go through everything you have written, go to the back of your book and try to rewrite each of these equations yourself. That's the practice you should do now. Try to rewrite and form each of the equations yourself, just to master the techniques. We'll go to solving problems using these equations in our next video.